Hello everybody. So for today's homework, I've chosen two different problems. One was from the section 4.8 and the other one from 5.2. So for 4.8, I really can't remember which question is this exactly. I just choose one randomly. So they're giving us an f of x, saying that 7 cosecant of x, cotangent of x, and it's asking us to find the antiderivative. So what I did here is I used this little symbol here to express that. Then we need to find the antiderivative of 7 cosine of x, cotangent of x, dx. So the first thing that just popped in my head when I saw this, it was this formula here. So the one main thing that I noticed of a difference was the sign for the equation. So I knew that since over here we have a positive, I knew that my antiderivative was going to be negative, because negative times negative, it's positive. So that's how I got this first part. Then I knew 7 is a constant, so I just plugged it here. And then since I knew already cosecant x, cotangent x, it was going to be cosecant, like it says over here, then I just plugged that in here too. So that's how I got my first answer. So for the second problem, I chose from 5.2, question 14. They're asking us to find the formula for the Riemann for this problem. They're telling us that we're getting everything, we're using the right hand endpoint of everything. That's going to be ck. They give us an interval between 0 and 3, and because I really like to see things, I kind of draw it here. And they're also asking us to find the area when n is approaching infinite. And they're also giving us the f of x. That's 9 minus x squared. So this is one of the things that's going to be very important that we need to remember. So one of the first things that I did here is actually I wrote the Riemann formula that's over here, because I figured that was going to help me out. So I kind of just split it and started figuring it out part by part. So the first part that I was looking for was for this first. So for that, we know that that's going to be the end point minus the start point divided by the number of subintervals. So that's what I did over here. And with that said, then I knew each interval was going to be 3 divided by n. Using that information, that helped me find my first x, and that's what you can see over here. So I knew that 0 plus 3 divided by n was going to be that very first x that I was going to be looking for. So I used that information and so that I could actually plug it on my function. So I did this here, and then I plugged this in my function here. And that gave me this little piece of information. Then now that was this. So because then we know that that's gonna change currently to which point in the which interval we're looking at, then that's why I added that k, so that we can go. We know that that's something that's gonna change accordingly. So once I logged everything in, I ended up having this information here. And with that, the first thing that I noticed is I had this 3 divided by n, and I knew that was a constant, so I figured I would just go ahead and take it out, and that's why it's here. And then I was left with just the 9 minus 9k squared divided by n squared in the inside. So I used this other formula that's of the differentials, where pretty much is telling me if I have the sigma of a minus b is going to be equal to sigma of a minus sigma of b. So that's the same thing that I did. and that's why we have this first portion here and the second one here. So from here, my next step was to start, let's do this. From here, then what I did is I knew this one was also a constant, so that's going to be this multiplied by this, as you can see here, as you can see over here. Oops. As you can see over here. And then the second one, what I noticed is this was going to be also a constant. So what I did is actually I took that out, as you can see over here. So with that said, I just resolved this too. So I got n and n, so they two got canceled, and I got 27, 9 times 3. And then I just multiply again 9 times 3 to get the 27 divided by n cubed. And then I was actually left with something very interesting. I was left with this. And we know that there is a formula for that. So what I did is I just went ahead and plugged that formula. So over here I just did all the math to figure out what was going to go on top, and then we know that was going to be divided by 6. So knowing that this was the result of what they were asking us for, so that will be our first solution. That's the Riemann theorem. So after that, they're asking us for what's the area when x is approaching infinite. So what I did for that is just get n as 0, x equals 0. So that's what I did for everything. So 0 cancel this, 0 cancel this, and then I was only left with 27 minus 27 times 1/3. So I just did third, and that was 9. And then 27 minus 9 was 18. And that is the area. Hope you guys like this. Please let me know if you have any comments. Thank you for watching. Bye-bye.